So in the second part, I want to describe how to find the ptolemy variety for finding representation into SL and C divided by plus minus the identity matrix. The motivation is that actually the most geometric representations for hyperbolic manifold will not lift. They live in pSL to C and they will not lift to SL and C. And you can modify the ptolemy variety to work and find representation into SLN, C divided by plus minus the identity, and thus actually also see the geometric representation of a hyperbolic free manifold. And to do this, you need to specify an obstruction class for lifting a representation in SLN, C divided by plus minus the identity to a representation in SLN, C. And this obstruction class is in the second cohomology group of M relative the boundary of M with Z2 coefficients. And I've again in Sage loaded the figure 8-knot complement, and the manifold now has a method called ptolemy obstruction classes. And if you call it, it gives you a Python list with all the ptolemy obstruction classes. So for figure 8-knot, there are actually two. The first one is trivial. So to understand this, this is the value this cohomology class takes on the zero phase of the zeroth tetrahedron. And it would take value 1. This relationship says that it would take value 1. Actually, that means 0. And this means that it takes the value 1. So in the ptolemy variety, we get a relation which says S00 has to be equal to 1. And here we would get as a relation for ptolemy variety that S00 takes the value minus 1. And I can now actually take a ptolemy variety in an even dimension where this is relevant. Or let me first save all the obstruction classes, and then I can take the ptolemy variety in an even dimension and specify what the obstruction class should be. So now I get the ptolemy variety for the trivial obstruction class, and if I change this to 1, I get the ptolemy variety for the non-trivial obstruction class. Doing this all over again is of course a little repetitive. So with the shortcut, you can actually just directly write, let's go take the trivial obstruction class, or take the non-trivial obstruction class. And maybe even that is too long for you, so you can just say, list me all obstruction classes, and then what I get is a Python list with all the obstruction classes. And then, for example, I can say, give me all the solutions. So I write solutions for every ptolemy variety, compute solutions for variety in m dot ptolemy variety to all. And now solutions is a list, and the first element in the list would be nothing, because there are no solutions for the trivial obstruction class, and then second element in the list would be all the solutions you get for the non-trivial obstruction class, but there's exactly 1, and you can now use the second index to retrieve this one. Okay.